Hey guys, it's Miss Miklos, and so just to recap, in our last lesson, we learned how we could use the ordered pairs from the unit circle to find the 6 trigonometric functions of a particular angle. And today we're going to be looking at that using another method. So today we're using right triangles, which is something that you are a little bit more familiar with. So I really want to stress to you guys, some of you may have really enjoyed doing the unit circle and that clicked with you and you want to memorize those ordered pairs. That's great. Others of you will prefer what we're doing today. That's great. I don't care which method you use. I care that you find a method that is successful so that you can memorize the important information. So we're going to zoom in here. And notice we have the angle theta. Okay, we often use Greek letters, as you guys know, to represent our unknown variable, or in this case, it refers to our reference angle. And that is an important term because all of the sides of our triangle are going to refer back to that particular angle. So here's our right angle. Okay, I know that the side that is opposite from our right angle is our hypotenuse. Okay, and that's not going to change regardless of where our reference angle is. Now our next side that I'm going to label straight across from our reference angle is what we call our opposite side. Okay, so this side right here is opposite from this angle. And then the last side that is next to or forming this angle, we call our adjacent side. Okay, so even if you guys feel super confident in this, often I will label the opposite, adjacent, and hypotenuse just to make sure that I'm not making any little mistakes in finding our trig functions. With those sides in mind, we are now going to talk about how we find the 6 trigonometric functions. In last year or the year before, you guys may have heard of Sohcahtoa, and I don't know what the heck I'm writing there. Here we go. Sohcahtoa. Okay, and Sohcahtoa is just a way for us to remember the 3 major trigonometric functions: sine, cosine, and tangent. And before we even get to that, I just want to point out right here that we have our angle. And the reason why this is important is because it is impossible for us to have a trig function without having an angle. So I should never ever see anyone just write sin or cos. We always need to have an angle afterwards. Okay, so back to finding out what this ratio actually is. Sine is so sine is opposite over hypotenuse. So I'm going to write opposite over hypotenuse here. And this opposite over hypotenuse is what we call a ratio. So we deal with an angle and we deal with the ratio. Cosine, cosine is adjacent over hypotenuse. So I'm going to write adjacent over hypotenuse. Toa means tangent is opposite over adjacent. Now, if we have those 3 memorized really well, the next 3 become pretty easy because these are all reciprocal functions. The reciprocal of tan is cotangent, so cotangent of theta is the adjacent over the opposite. Secant and cosine are reciprocals, so secant is hypotenuse over adjacent. And cosecant and sine are reciprocals, so it is the hypotenuse over the opposite. So these are the 6 trigonometric functions we're going to be using today. And we're going to see these problems in 2 major ways. One of the ways is going to be dealing with a particular triangle where we're just calling the angle theta, and we just know some information about the sides of the triangle. The other ones are going to deal with our special angles, so 30 degrees, 45 degrees, and 60 degrees. Okay, so we're going to use this little chart here, and I don't like that it says theta because let's just think of this as number 1 number 2, and then number 3. So what we're going to do, I'm going to give us some information on this problem, and then we're going to find all 6 of these trigonometric functions. Note, our figures are not drawn to scale, and that is important because sometimes we might think this can't possibly be the right answer, when in fact we don't draw our triangles to scale, so it's okay. So let's say theta is that lower left-hand angle. And let's say that this side is 5 and this side is 13. Okay, so a lot of times you'll get problems like this where we are given 2 sides of a triangle and I do not know the third side. So I'm going to use Pythagorean theorem, which in my opinion is one of the most important things that you learn in geometry. So just a reminder, 13, our hypotenuse in this case, always represents C. So I'm going to say a squared plus 5 squared equals 13 squared. And as I work through this problem, I end up getting a squared equals 144. And when I square root both sides, I get a is 12. And one quick note, we are really used to, when I square root both sides, putting plus or minus out in front. When in fact, in this particular case, I do not, because we just have a triangle and we know a distance cannot be negative. So this is always going to be positive. Now, when we move into our next lesson and we talk about things on a graph, then we may have some negative sides because that side length is not negative, but the direction is negative. So just kind of to give some perspective. Some of you also may remember what we call a Pythagorean triple. Okay, so you may have known that 5, 12, and 13 was a Pythagorean triple off the top of your heads. Okay, the other one that we see quite a bit is 3, 4, and 5. And it honestly doesn't really matter if you have these memorized or not, okay, but it can save us some time. So we're going to start. So I'm starting from our reference angle. Sine is opposite over hypotenuse. So I'm going to go ahead and write 12 over 13. There we go. In fact, I might just go ahead and write opposite, adjacent, hypotenuse, just to help myself out. Cosine, adjacent over hypotenuse. So I have 5 over 13. Tangent is opposite over adjacent. So I have 12 over 5. In my opinion, I think the most difficult part here is making sure that we find this missing side correctly. Because I think for the most part, we remember Sohcahtoa, okay? We just notice that if I mess up this side, I'm going to miss a lot of these problems. Okay, looking ahead now, it's asking me to find cosecant. I know cosecant is the reciprocal of sine, so I'm going to flip sine and get 13 over 12. Secant is the reciprocal of cosine, so I'm going to get 13 over 5. And cotangent is the reciprocal of tan, and I'm going to get 5 over 12. So let's go ahead and look at number 2. Okay, for number 2, let's say our sides are 1 and 3. Okay, so this time I do not know the hypotenuse, so I'm going to say 1 squared plus 3 squared equals c squared. So I end up getting 10 is c squared. I cannot simplify that radical at all, so we're going to say that the hypotenuse here is radical 10. So 3 is my opposite, 1 is my adjacent, and radical 10 is my hypotenuse. I'm going to start with finding sine. Sine we know is opposite over hypotenuse. Some of you guys might just write 3 over radical 10. And I'll let you guys know that if it was a free response type quiz or assessment, I would fully give you guys full credit for that. Fully give you full credit. Not just kind of give you full credit. But we know this isn't the best answer, even though it is correct. The best answer would be if we rationalize it, and just to review, we would rationalize by multiplying by radical 10 over radical 10, which would give me 3 radical 10 over 10. Now, on a multiple choice, this is the type of answer that I would give because that is the most correct. But on a quiz, if you guys just gave me that, or on a test, if you gave me that, if it was open-ended, totally fine with that. Okay, moving back here. A cosine adjacent over hypotenuse. So I have 1 over radical 10 or radical 10 over 10. Tangent, opposite over adjacent. So I have 3 over 1, which I'm just going to write as 3. I know cosecant is the reciprocal of sine, so the reciprocal of 3 over radical 10 is radical 10 over 3. Secant, the reciprocal of 1 over radical 10, which is what this originally was, would just be radical 10. And cotangent is the reciprocal of 3, because that's the tan value, so we would get 1/3. Okay, so a lot of your problems on the suggested problems are going to look like this. Now we're going to transition to number 3 here. Oh, there's a reminder at the bottom. Hopefully we already know this. When one side of a right triangle is missing, use the Pythagorean theorem to find it. And the key is, and we'll learn about this later on in chapter 6, which is second semester, it does need to be a right triangle. Okay, if we don't have a right triangle, we actually can't do anything that we're doing right now. So if we look at number 3, you guys might be thinking, oh shoot, this is different. I don't know what we're doing. But since this is cosine, they are actually telling us that this is the adjacent side and this is the hypotenuse. So in actuality, it is exactly the same as our previous problems. Okay, we have 2 sides of a triangle. So I'm going to go ahead and say 2 squared plus b squared equals 3 squared. So I get 4 plus b squared equals 9. So b squared is 5, and b is radical 5. So I have found here that our opposite side is radical 5. Now we can go ahead and find our 6 trigonometric functions. And in actuality, no one should miss cosine or secant because it's given to us. So I'm actually going to scroll up here. It's kind of a long ways away. Let's zoom out a little bit. There we go. There we go. Lots of writing going on today. Okay, I'm going to write that cosine is 2/3 and secant is 3/2. And I will be super, super sad if anyone misses those. Okay, tangent is opposite over hypotenuse. So I have radical 5 over 3. Tangent is opposite over adjacent. So I have radical 5 over 2. And at this point, now I'm just doing reciprocals. So the reciprocal of cosecant is going to be sine. So I have 3 over radical 5, or 3 radical 5 over 5. We already found secant because that was the reciprocal of the given information. Cotangent is the reciprocal of tan, so I would get 2 over radical 5, or 2 radical 5 over 5. So about half of the homework that you're going to see deals with problems like this. The other half of what we're doing is going back to this special angle. So we have 2 special angles, 30, 60, 90, and 45, 45, 90. So I'm going to zoom in here. And last class we learned about the unit circle. This is another method. So I'm going to label this 30 degrees and 60 degrees. Just a little kind reminder, 30 degrees is pi over 6. 60 degrees is pi over 3. And we made those connections last class that a denominator of 6 is always going to be a reference angle of 30 degrees, a denominator of 3 is always going to be a reference angle of 60 degrees. Opposite from 30 degrees, we have 1. Opposite from 60 degrees, we have radical 3, and our hypotenuse is 2. Okay, so this is definitely something that you guys should have memorized. In fact, I'm going to actually suggest that we memorize some information we get from using this. Okay, our other one, we have our 45, 45, 90. We know 45 degrees is pi over 4, and our side lengths are 1, 1, and our hypotenuse is radical 2. So these are the two special triangles that you guys used a lot last year, and we're going to use them a lot right now as well. So we're going to start just by focusing on 30 degrees as our reference angle. So that would be pi over 6. Sine of 30 degrees is opposite over hypotenuse, or 1/2. Cosine is adjacent over hypotenuse, which is radical 3 over 2. And tangent is going to be opposite over adjacent, which is 1 over radical 3, or radical 3 over 3. These are the 3 trig functions that we really need to have memorized, and you may recognize that this is the y value of the ordered pair. I'm sorry, this is the x value of the ordered pair, and this is the y value of the ordered pair that corresponds with pi over 6 on the unit circle. Okay, the next one we're going to do is 60 degrees. 60 degrees is also pi over 3. So if I'm going off of 60 degrees, okay, sine is opposite over hypotenuse, so I have radical 3 over 2. Cosine is adjacent over hypotenuse, which is 1/2. And tangent is opposite over adjacent, which is radical 3. Lastly, 45 degrees, this is pi over 4. Okay, if I look at 45 degrees, I have 1 over radical 2 for our sine, which is radical 2 over 2. Cosine is adjacent over hypotenuse, which is also radical 2 over 2. And tangent is opposite over adjacent, or 1. My advice to you guys is that you have this chart right here, memorized. Okay, these 9 trigonometric functions come up all the time. We need to know them off the top of our heads. Okay, if you guys think about it, in 3rd grade, you guys memorized multiplication. You had multiplication tables, you took those time tests every day in math class, and eventually we learned how to multiply things and have those values off the top of our heads. This is really the same concept, where these are values we need to have memorized. In fact, the next time I see you guys, we are having a timed PowerPoint quiz. What I mean by that, it is going to be a PowerPoint that is going to display one specific problem, like sine of pi over 4. You will then have 30 seconds to tell me that that is radical 2 over 2. Okay, if you have these 9 memorized, it's super easy. Okay, other options, you could memorize these 2 triangles and then just go, okay, sine of pi over 4 would be 1 over radical 2. It would take a little bit more time to draw these out, but you would still be doing the correct thing. Third and final option is we could use the unit circle. So this means this weekend you need to study. Okay, final thing we're going to talk about is cofunctions. I know some of you guys have maybe wondered, like, why is it sine and cosine, tan and cotangent, secant and cosecant? And the reason is cofunctions of complementary angles, so just to remind us, that means that the sum is 90 degrees, are equal. So that tells me that the sine of 30 degrees and the cosine of 60 degrees are equal to the same value, because 30 and 60 are complementary. Okay, and this is something you may not ever use, but I think it's just kind of interesting. Secant and cosecant, secant of 45 and cosecant of 45 are both radical 2. Tan of 60 and cotangent of 60 are both radical 3. So that's just something kind of interesting that can help you in some of your problems if you want to save time doing that. Okay, major thing though, memorize this chart right here. Okay, we need to have these values memorized.